the last problem that seemed to be a consensus of what you guys wanted to look over was question 39. So let's review and read aloud. It says a 1 kilogram mass weighs 9.8 newtons on the Earth's surface. And the radius of Earth is roughly 6.4 times 10 to the 6 meters. Calculate the mass of Earth. All right, well, doing that, it's kind of just like the problem we did previously in calculating the mass of an electron. So when doing that, what we're going to talk about is using the formula F equals gravitational constant mass of the object. And since we're talking about the mass of Earth, let's characterize it as big M with an E subscript all over R squared. Well, since we want to solve for the mass of Earth, let's do that right now. Multiply both sides by R squared. Divide both sides by gravitational constant and the mass of the other object, which will cancel out that. And now let's just clean it up. Force R squared over gravitational constant by the mass of the object will equal the mass of Earth. So when we sub that in, we know that the weight of the object, or the force, is 9.8 newtons. The radius was given in the problem, 6.4 times 10 to the 6th meters. And remember, that's squared all over the gravitational constant, 6.67 times 10 to the negative 11 Newton meters squared, kilograms squared, times the mass of the other object, which is 1 kilogram. So cleaning that up, newtons cancel out here. Remember, this meters squared, this meters will cancel out once that is squared. And this kilogram down here, this will just reduce down to 1 kilogram at the bottom of a fraction on the bottom of a fraction, which we know will come up top. And that unit ends up making sense. And when we plug that into our calculator, the book answer gives us 6.0 times 10 to the 24th kilograms. And that is also, I believe, a mass in the table that we can check. And just remember that the book rounds to sig figs. But now we move on to the part where a lot of you guys probably got a little bit hung up, but it's not that difficult. We just have to remember a little bit about geometry and chemistry. So first of all, when we're talking about density, we got to remember that density was equal to the mass divided by the volume. Well, we have the mass. All right, so that's understood. Well, how do we get volume? Well, if we remember, Earth is a sphere. So if we look up the volume of a sphere, that's 4/3 pi r cubed. So when we look at that, well, what is the variables that we need? We just need the radius. So we have 4/3 times pi, and the radius we have right here. So let's bring that in. So when we have that, we bring that in and we go 6.4 times 10 to the 6th meters. And remember, that is cubed. And when we get that number will be 1.1 times 10 to the 21st meters cubed. And remember, that makes sense. It's meters cubed because we're talking about volume. And as always, remember that the book rounds to sig figs. So I might have a little bit of difference, and I'm not putting in my calculator at the moment just to save some time in the video. So then we have the mass. Now we have the volume. We're going to take 6.0 times 10 to the 24th kilograms per 1.1 times 10 to the 21st meters cubed, mass, volume. Then we can calculate density, do the division, and when we do the division, we should get somewhere around 5.5 times 10 to the 3rd kilograms per meter cubed. I hope that's helped. go over a couple of these problems and get you guys moving in the right direction. Keep up the great information, the discussion, ask questions when needed, and just do your best. Remember, this isn't the best situation that we have, but we need to make the best of what we got. So if you have any questions, keep up the questions coming through Remind, add questions or discussions to our team, and just continue working. Try to give yourselves an ample time to do the work and understand that there could be technical problems at any given time. So just make sure that you don't do things last minute to give yourselves the best opportunity to complete. I wish you guys all the best and look forward to hearing your comments. Thanks.